Good morning, good afternoon or good evening from GFoRSS TV.
Good morning, good afternoon, and good evening. And thank you for joining us for the 5th broadcasting session of the Global Food Regulatory Science Society TV, the GFoRSS TV. I am your host for today, so please let me start by presenting myself. My name is Amin Kassouf, and I am a research manager at the Global Food Regulatory Science Society. And I am so thrilled to take you through today's session, which will be devoted for pesticide residue analysis. Our today's broadcast is taking place at the Dubai Central Laboratories affiliated to the Dubai municipality. So here I would like to seize the opportunity to thank the DCL staff and team, as well as the Dubai municipality leadership for their heartfelt welcoming and their unwavering support. Moreover, the broadcast is happening in the framework of the Africa Food Safety Laboratory Capacity Enhancement, which is a training ongoing right now and taking place from the 24th of July until the 3rd of August, from 9 African countries, joining well-esteemed trainers from Africa, from Dubai, taking a training dedicated and devoted to multi-residue pesticide analysis in food, as well as mycotoxin determination in food. This training is funded by the USDA and the USAID, with support from the Waters Corporation, our Biofarm, in partnership with the AOAC International, represented by its 2 regional sections, the Sub-Saharan African section, as well as the Arab section of AOAC International, in collaboration also and support from the African Union, implemented by the Institute of Nutrition and Functional Food, INAF, of the Université Laval, as well as by the Global Food Regulatory Science Society, GFoRSS. So here I am so honored to welcome with us today for the opening of this session, the CEO and the board president of the Global Food Regulatory Science Society, Professor Samuel Godefroy. Welcome, Professor Godefroy, with us today.
Thank you.
And please, if you can give us some opening remarks for our today's session.
Thank you very much, Amin, and good afternoon from Dubai, good morning, good evening, wherever you are around the world. It is indeed a special occasion today. We are holding the 5th broadcast of GFoRSS TV in the context of holding this training that is taking place in the Dubai Central Laboratories in partnership with the Dubai municipality, welcoming 10 African scientists on a hands-on training on pesticide determination. And it is great also to see that today's theme is on pesticide determination in food. This gives me also the opportunity of sharing with our viewers and those who support our society a number of pieces of news. Obviously, ones concerning GFoRSS TV, we are hoping to continue to receive your comments, your support, and your input as to future topics of interest that we can devote to these broadcasts on social media. But also, what we would like to do is to change the rhythm of our broadcast. After 5 consecutive broadcasts that happen on a weekly basis, we will be shifting on an on-demand basis. So essentially, my message to all our viewers, please subscribe to our YouTube channel, to the LinkedIn page, as well as to the Facebook page of the Global Food Regulatory Science Society. And you will be receiving notifications when we will be having live broadcasts related to GFoRSS TV. Now, we will be continuing our efforts of knowledge dissemination. And we have planned, in fact, a number of events, and it gives me pleasure to announce those. They are being programmed in the upcoming period. Certainly, our Global Food Regulatory Science Symposium the second edition, in fact, of the symposium. And just like last year, we are planning to have the second edition on the margins of the Dubai International Food Safety Conference. In fact, a couple of days before the launch of the conference, from the 30th to the 31st of October 2022, here in Dubai, but also being streamed live and using a hybrid format. So, of course, we welcome those who will be able to join us in person, but for those who can't, hopefully we will be able to reach you through our live broadcasts. And as part of the Global Food Regulatory Science Symposium, we planned a particular day, and that's on the 31st of October, that will be dedicated to the first annual meeting of the Arab section of AOAC International. So we will have, in fact, a day dedicated to food analytical applications and, of course, to activities that are taking place in this region. So I hope that we will have many of you joining us in person and others joining us live on social media. And again, I would like to express my thanks to all those who are making this possible, definitely to those who contribute to the programming, to yourself, Amin, but also to Dr. Ali Bouyazbek, who has been, in fact, at the helm of directing this series of GFoRSS TV. And of course, to you, our viewers, I hope that your number will increase and that you will be accompanying us as we continue our journey of knowledge sharing and knowledge dissemination. Thanks once again for having me, and I wish you all a great broadcast.
You are watching GFoRSS TV. Today, on GFoRSS TV.
The term pesticides is normally used to describe a broad class of substances or mixture of substances intending for preventing, destroying, or controlling any pest. These compounds have become a crucial tool in modern agriculture, enabling the producers to maintain the quality of their livestock and crops in the most efficient way. However, the use of these substances and products presents a risk of exposing consumers to critical levels of harmful chemicals through residues that remain as the animal is reared or as the crop is processed. Consequently, an urgent need surfaced for multi-residue analysis methods to screen, identify, and quantitate these substances and compounds in food, as many pesticides as possible, to achieve optimized operational efficiency and consistent data quality, helping thus to enforce regulatory compliance and ensure food safety at national and international levels. During today's session, we will have the chance to assist to training sessions given by Dr. Kaushik Banerjee and Mr. Srinivas Joshi, which are the chair and the president of AOAC India section respectively.
Coming up next, on GFoRSS TV.
So, good afternoon. I hope you remember that yesterday we had a lot of discussion on evolution of multi-residue method. And what I said that the major evolution or major progress in pesticide residue analysis happened in 2003 when the QueChERS method was established. So this method basically it is a name derived from certain words like quick, easy, cheap, efficient, rugged, and safe. So what they did, they discovered that if you take a sample of fruit or vegetable, if you homogenize it and then extract it in a solvent like acetonitrile, then what happens? Normally, when you add acetonitrile to anything, it gets mixed up because fruits and vegetables have a lot of water, a lot of moisture. For example, today we are going to see what happens when you extract some tomatoes. Tomatoes have a lot of water, grapes have a lot of water. So when you homogenize it, it is basically a kind of a soup sort of thing with a lot of moisture in it. So when you add acetonitrile, they get mixed up. But when you add a combination of magnesium sulfate and sodium chloride, they found that if you add this, you shake it, and then put something, some for some time, and then you will see that these two layers get separated. So basically, this is a pre-mixed QueChERS kit. So if you do not have it, then in your lab, what you can do, you can take an empty 50 ml or 15 ml. I think 50 ml is the best idea. 50 ml centrifuge tube, which is a regular centrifuge tube, you can see. It can go into the centrifuge instrument. So then you have to, with a spatula, you have to add your sample homogenate, say 10 gram or 15 gram. Then you add 10 or 15 ml acetonitrile. So whichever amount of sample homogenate you add, the same proportion of acetonitrile solvent also should be added. Okay. Then you add magnesium sulfate and sodium chloride. You can also have magnesium sulfate and sodium acetate. Yesterday I explained that there is a EU method where citrate buffer is used. So three QueChERS versions are there. Whichever combinations are there, you can probably use anything. And then you shake it vigorously. If you do not shake, then what happens? Magnesium sulfate will combine with water and it will form some lump. So what you do, you add the things, then you shake it very vigorously. So here you have a pre-weighed combination of these salts. But if you do not have a pre-weighed combination, then what you have to do, you have to take the homogenate, add your solvent, add magnesium sulfate, shake vigorously, then add salt, shake vigorously. Okay. So then you can put it into the centrifuge tube and a centrifuge instrument, and then do centrifugation as per the protocol. And after that, you will find that there are two layers. Upper layer will be acetonitrile, lower layer will be water or aqueous. So from the acetonitrile, you have to take an aliquot. It can be 1 ml of the extract, which will go for further cleanup. Is there any confusion in this? So normally what they did when the QueChERS method was developed, they explained it. That's a very good exercise because depending on the size of your palm, you can take probably, say for example, these two I can hold, or maybe another two also I can hold, depending on the size of your palm. So here two, then you do this. So it's a very good exercise for your arms. And if you do not do it properly, then what will happen? Your your all muscles will grow. If you do 30 samples a day, it's enough exercise. and you can't do it in sitting condition. You have to stand and do it. So what happens after you do, you put it into the centrifuge tube, in the centrifuge instrument, centrifugation, take it out. You will find two separate layers. From the upper layer, you take an aliquot, and then you go for the cleanup. So here again, you can see that this is the combination of cleanup which they have put in a tube. It's already pre-weighed, but you need not worry about it. If you do not have this kind of pre-weighed tube, you can purchase primary secondary amine, you can purchase C18, you can purchase gravitized carbon, you can purchase any solvent from the market, and you can weigh in your laboratory, and with a spatula you can add to that 1 ml of the solvent extract. So here for your advantage, they have already got some pre-weighed tubes. So here you can see it is mentioned 150 milligram magnesium sulfate, 50 milligram primary secondary amine, and 50 milligram of C18. So this is the cleanup tube. Okay, so you have to take one tube, you have to open the tube, you have to put 1 ml of the solvent extract, then again do this. Or if you have a vortex instrument, that is a very good idea that you put it in the vortex and it will grrr, it will happen, and then entire thing gets mixed up. Here it is very important that your extract should come in very good contact with these solvent combination, because it is used for cleanup. So in your extract, whichever fatty acid is there, whichever sugars are there, these should come in contact with these things. Even lipids, they will combine with C18. So as much contact you will provide, that is good. One very good thing is that they don't combine with pesticides. Most of the pesticides do not get absorbed on them. So that's an advantage, except few compounds are there which are also very well reported in literature. So based on that, you can decide that which compound may have some absorption loss on these tubes. But that's a part of your any analysis, because if you have hundreds of compounds, some or other compound will have some interaction with them. So in that case, you should have some special precaution. So here one important thing is that these materials which are inside, we can expect that these are all activated. They do not have any absorbed moisture. If you want to use in your laboratory, you should remember that all these adsorbents, whatever you maintain in your lab, they should be maintained in a clean condition. You should not unnecessarily open it and expose to atmosphere, because in that case they will get contaminated, and we don't want to add any contaminant through your cleanup solvents, because it is for cleaning purpose. The material which is used for cleaning purpose should not contaminate your extract. So that's very important. And one important concept in QueChERS method is that everything is done in closed condition. So if you see here, this extract, whatever is happening, everything happens after you close the tube. So here you add all the things, then you have to tightly close it. Okay, so nothing escapes and nothing gets exposed to the outside atmosphere. So we avoid basically moisture, contaminated air, whichever may be present, because finally we are going to estimate by mass spectrometry, whether it is GCMS or LCMS. And if you use it in a clean condition, then the best thing will be that your background noise will be less. So entire extraction happens in a closed condition, and similarly entire cleanup happens in a closed condition. Nothing is open here. So here also you have to open, add the solvent, close it. So these are certain very important things, that why QueChERS extract is easy to handle. because we don't get exposed to any solvent vapor. Everything is closed. That's a big advantage. And after you clean up, means after you centrifuge these tubes, normally at 10,000 RPM or so, you have to put in a Eppendorf sort of centrifuge, where the rotor head has capacity to take this type of small tubes. And after you centrifuge for some few minutes, then you will see that all the solids they get sedimented, and at the top there is a clean extract. Okay, so from that you have to pipette out, put it in the auto sampler vial, and inject into the instrument. So this is basically QueChERS method. So if you do not demonstrate it, do you believe you will be able to do it? Confidence? Confident? Huh? Because it's so easy. You take a tube, if something is there in the tube, that's so good. If something is not there, you weigh, measure, add. Sample anyway, you have to do homogenization initially. Once you get some tomato, mango, banana, or whatever material, you have to chop it, you have to homogenize it. After that, take 10 gram homogenate into it. If it is the AOSC method, take 15 gram homogenate into it. So whichever amount of homogenate you will take, the same quantity of solvent also you have to add. Then after that you close it, vigorously shake so that they get mixed up very well. If it already contains magnesium sulfate, sodium chloride, or magnesium sulfate, some buffer, then what will happen? You have to vigorously shake so that they don't form any lump. So after that you put it in a centrifuge where the rotor head should have 50 milliliter capacity tubes. So you do centrifugation and you will see that there are two layers. Upper layer is your acetonitrile layer. So with a pipette you take an aliquot from the upper layer, put it into that small one. This is for cleanup. This is for extraction. This is for cleanup. This is for extraction and this is for cleanup. So you have to open it. You have to add 1 ml, close it. Do handshaking. Better to put on a vortex mixer, and then after that put it into a centrifuge. After centrifugation, from the upper clean extract, you take again by a pipette, you take the aliquot, put it into the autosampler vial, place it into the LCM SMS or GCM SMS. Then rest will be the instrumental analysis. It's fine? Okay, so this part is done. Yeah, so that protocol will be provided. So initially what happens, say this is plastic. You can do say 5,000 RPM or like that. Nothing, there is no problem. If it is a glass tube, then you should take care that you should not use a high RPM, then glass will break. But there is no problem for this type of things. Same is the case for this. In case of cleanup, normally we say that at a more speed you should do it so that these fine particles should come in very good contact with the extract and remove all the or most of the co-extractives. Okay, so it should appear a very reasonably clean extract. Reasonably means yesterday I told that so that selectivity of the LCM-SMS or GCM-SMS is complementary to it. So when you inject it, you should get nice signals. Okay, yeah. So this is basically an optimization step. So if you look at any analytical chemistry paper, normally they do certain optimization in the beginning. So first optimization is sample size. Okay, how much should be the minimum sample, so that you should achieve 10 parts per billion limit of quantification. Because in case of pesticide, as Mr. Joshi has explained yesterday, that your default MRL is 10 parts per billion or 0.01 milligram per kilogram. Okay. So if this is so, for example, that or here. This. So or 10 parts per billion. Okay. So you should optimize your method in such a way that at least your limit of quantification should be less than or equal to this. This is very important. Yeah. At least this is important. So here certain optimization means when the QueChERS method was developed, then what they did, they optimized sample size, optimization, sample size, sample solvent ratio. Okay. So they understood that 1:1 ratio is the best way, so that if the residue concentration is very low or the residue concentration is quite high, everything should be extracted in this solvent. Okay. So and then when you take this centrifuge tube, we should get very good separation, phase separation. So this is aqueous, this is acid. Okay. A very clear separation is achieved. So based on all these things, they propose the method. So that is the rationale, that when you take this part and when you estimate the residue, you should get recovery or accuracy, whatever. These both are the very same things, as close as to 100%. So they say that 70 to 120%. Why it goes up? Because of matrix effect. We'll explain it later. So normally our objective is that if my concentration is 0.1 ppm or 100 ppb, we should try to get 90 to 100% accuracy. If not, at least 70 plus, more than 70% accuracy, and your precision, that means precision means same sample, you take 6 tubes, 6 analysis of the same concentration, same material. So whatever residue you get, for example, your actual concentration is 0.1. So you get 0.009, 0.101, 0.11, 0.12, 0.13, 0.007 or 0.008. Okay, so 1, 2, 3, 4, 5, 6. So whatever relative standard deviation you get, that should be less than 20%. This is the requirement. So if these requirements are fulfilled, you have optimized the method. So for example, your name is Esther. Okay. For example, Esther analyzes 6 samples. Okay, so she should get a very good RSD. It would be less than 10% because same person is doing. Now one situation Esta has also done and Bazi has also done. There is a possibility that if we take 1, 2, 3, 4, 5, 6 and if we take 1, 2, 3, 4, 5, 6 and 6 plus 6, 12 result, if you estimate RSD, this could be say 11% or 12% because two different persons, their pipetting error may happen, they may be having some other problems in relation to their experience, etc. So variation. Then you are doing here and suppose his lab is in a different place. So you have done 6 sample, he has done 6 sample. So in that case RSD may be furthermore say 14%. This is lab to lab. So these are all reasonable things. Like if I do myself, my error will be the minimum. Whichever mistake I do first time, same mistake I do 6 times. So my RSD will be always low. Now when I do something, he does something, I may be more accurate than him or he may be more accurate than me. But then our result, my result and his result will be slightly different. So if we calculate RSD based on my result as well as his result combination, then RSD will be slightly higher. Now we transport the sample to her lab. It's in a different place. So naturally everything is different. So maybe if we do interlaboratory data, RSD will be further higher. So normally it is said that if the method is very well optimized and if the method has a very simple protocol which is not difficult to implement, in that case probably you can expect that RSD should be always less than 20%, whether it is intra or interlaboratory. So in that situation probably lab to lab variation will be less. So in case of international trade, when something from Ghana comes to Europe or something from Nigeria, it goes to Germany. So a laboratory result in Nigeria or a laboratory result in Ghana and the laboratory result for the same sample in Germany or Netherlands should be very similar. Okay, so what do you mean by similarity in analysis in case of trade? That means what are the pesticides detected in Ghana, what are the pesticides detected in Germany, and which concentration estimated in Ghana, which concentration estimated in Germany. If they are similar, then they have a mutual confidence on them, on each other. And mutual confidence always build up trade. Trust, confidence. So naturally trade volume will increase. So that is the biggest thing what we probably can contribute as the residue analyst. We can give lot of confidence to the trade partner people, trade chain, entire supply chain people will have lot of confidence on it. Okay. You are asking some question. See, most of the matrix, one were responsive. When it was developed, it was basically developed for fruits and vegetables. Okay. Now you will see that QueChERS method is for everything. A slight modification, that's all. Slight modification in terms of cleanup. That's all. For antibiotics also, for environmental matrix, for soil matrix. Everywhere people are using the same thing. Suppose in case of very fatty matrix, what they do, you have to just modify a little bit. So you take the aliquot, you put it in a freezer, so they get solidified and they removed. So this is a slight modification in your analytical procedure, and these modifications are all basic school level or maybe graduation level chemistry. Nothing very specific. We all know that at a low temperature, fat gets solidified. So you put it in that freezer, it gets solidified. So you centrifuge, then it gets removed. So it doesn't require a very high flying chemistry knowledge. Phospholipid. Even people have nowadays cleanup materials which can selectively catch chlorophylls. So plenty of new innovations are there in sample preparation. You should just see literature, and maybe many of the service providers and technical partners, technology producers, they will be able to help you in giving the exact what material you should use for your particular matrix. Yeah. So in case of formic acid, what happens? Like normally what happens? Normally whenever any material, its pH is alkaline. For example, carrot. Once I studied in a science newspaper that those who develops indigestion and acidity in stomach because of excess secretion of hydrochloric acid, they should eat lot of carrot, because carrot is slightly alkaline. So if carrot is slightly alkaline, and if you would like to estimate organophosphates or carbamates in that, then you should know that organophosphates and carbamates and even synthetic pyrethroids, they are prone to hydrolysis. And hydrolysis mainly happens in an alkaline pH. So as a residue chemist, my objective is that if I get this sample for analysis, I should not do anything to degrade whatever residue it contains. My job is very neutral. I am not emotionally attached with this. This sample should not have any emotional attachment. Many people will request you that my sample should pass. Suppose you appear for examination. What is your expectation? You should pass. Okay, but the examiner should feel that, okay, the student who has studied, he should pass. The student who did not study, he should not pass. As simple as that.
Coming up next on GFoRSS TV.
We are honored to have with us today here at the Dubai Central Labs, Dr. Koushik Benraji, the principal scientist at the National Reference Laboratory, the National Research Center for Grapes, India, and chair of the AOAC India section. Welcome, Dr. Koushik. And thank you for being here with us today. And thank you for the previous session we were watching right now that you gave in the framework of the ongoing training here at the Dubai Central Labs. Dr. Koushik would like to benefit from your presence here today with us to discuss and share a few ideas with you. So if we start, how can you define the main scope of pesticide residue analysis particularly in relation with regulatory compliance and trade facilitation.
Okay, I'm very happy to be here in this Dubai Central Laboratory, and I'm honored that GFoRSS organized this training with me as one of the trainers, and I'm very happy to contribute in this training session. So coming to the question that you have asked, you know that pesticide residue is a traditional problem for all food safety. All over the world, if you look at the trend of rapid alerts that Europe usually reports for various commodities, every year we get several rapid alerts for various countries which relate to pesticide detection in either fresh or processed commodities. So now what happens that if you have a domestic regulation in your country, usually the scope of analysis includes most of these pesticides, because pesticide residue may come or may appear in a commodity as a result of direct application by farmer, but it also may appear in a commodity because of aerial drift from adjoining fields, because of contaminated agro inputs like manures, fertilizers, various plant extracts which may have certain concentration of pesticide because of some previous applications, and of course certain environmental matrices like soil, water, etc. So in such cases, your scope of residue analysis should cover as many pesticides as possible, and that probably is the key for today's multi-residue monitoring, so that a commodity or a consignment of food, once it is tested for a maximum number of pesticides, it is probably fit for export or fit for trade in any of the destination markets, whether it is within the country or it is outside your country or maybe outside a continent. So key rule is that you should target as many compound as possible. Thank you. I hope it answers your question.
Of course, thank you so much for your value. About the evolution of pesticide residue analysis methodologies in the last decade?
So if I consider my own experience, I started doing residue analysis when I was a PhD student. So since from those dates, like in 90s to this period, the current situation, we see that there are two distinct phases in pesticide residue analysis, before 2003 and after 2003. So before 2003, we had several AOSE official methods in place, which were based on multiple extraction and cleanup steps. And there we were heavily dependent upon extraction by using liquid-liquid partitioning. And various cases, the sample preparation workflow required chlorinated solvents. So because of health hazard and hazard to environment and pollution problems, many of these methods got discontinued, and another problem was that they had too many steps to perform, and that was the reason lab to lab variation in test result was unacceptable in many situations. In 2003, you probably know that QueChERS method was established, and it is really a nice method which came up to the expectation of all analysts across the globe, because it's a very simple process where you just homogenize a sample, add some acetonitrile, add quantified quantity of salt combination, and that's all. By centrifugation, you can have clear phase separation. And the acetonitrile layer is injectable to GCMS as well as LCMS instruments. So this made life of residue chemists quite easy. So in parallel, there is ethyl acetate extraction process, which is basically a method from Swedish Food Agency, then Netherlands Food Agency, and also in India since 2004, we are using this ethyl acetate extraction based method that was largely optimized in my lab. And these methods basically they cover most of the pesticides in multi-residue extraction. But if you think of other kinds of compounds, like there are polar pesticides, there are ionic compounds, so you need to have separate single residue methods for them. So basically these days a typical agricultural sample, whether it is a fresh commodity or processed product, its analysis requires multiple extractions. One large scale multi-residue extraction, then one extraction for plant growth regulators, and certain single residue methods which will include maybe ionic compounds like glyphosate, etc., paraquat, diquat, dithiocarbamates. But currently there are new methods are coming up because of new column chemistries. It is also possible to integrate a large number of polar and ionic compounds in a single method. This is the current scenario.
Thank you so much. In the same framework, so what do you think should be the main techniques to be used by laboratories for regulatory compliance testing when dealing with pesticide residues?
So basically these days we always we always say that there are two different techniques. One is GC-MSMS and another is LC-MSMS. You can understand that in both cases the instrument basically relies upon the tandem mass spectrometry, where detection and confirmation as well as quantification, everything happens together. So a typical residue analysis workflow, whatever extract it is produced, that have to be injected into both kinds of instruments. So normally a standard residue analysis laboratory should have at least one GC-MSMS instrument and two LC-MSMS instrument, so that they can analyze all non-polar compounds like chlorinated hydrocarbons and synthetic pyrethroids in GCMS, and in LC-MSMS they can analyze the multi-residue extracted sample for whether it is acetonitrile or ethyl acetate. Ethyl acetate layer have to be converted into methanol water combination by solvent substitution, and then one injection is required for these plant growth regulators. And these single residue methods are also basically largely methanol extraction based. So 2 LCMS triple quad will be very much essential for any standard laboratory. But advanced laboratories also should have high resolution mass spectrometric instrument in combination with GC or HPLC, so that non-targeted analysis can also be performed.
Time and all these valuable information you gave us today. Thank you so much, Dr. Kaushik, for your presence with us.
It's my pleasure. Thank you. Thanks for this invitation. Thank you.
Coming up next on GFoRSS TV.
Good afternoon. Hope you had a good day in the practicals now, right? Majority of the parts now you have learned. Now we will look at what are the practical considerations we need to have for the pesticide residue analysis. So before going into the practical pesticide residue analysis practical part, we will just have a look at what are the practical considerations you need to have. Sorry. So today quickly we will have a look at what are the background for the food safety testing, multi-residue analysis, what are the background, sample preparation part, separation, detection, and what are the key conclusions need to be considered to approach for the analysis of pesticide residues. As you have seen, we have been talking since last 2-3 days. Basically, the key drivers for the food safety testing, one is very important is the regulation part, okay? The surveillance, national monitoring program, as well as import and export certification programs. Then economic part, the band differentiation, marketing, increasing consumer prosperity, increasing consumer confidence. And public scrutiny, it's basically brand protection, food scares, and also adulteration and food fraud. Now, when we look at the challenges across the food safety, increasing volume and diversity of the food, what and when to test. That's one of the key challenge. The second, increasing population and the food demand. So that means effectively we need to grow more and more food. So we must produce more food over next 50 years than what we did for last 500 years. Okay? And public awareness. There is a growing public demand for greater health protection. Even a consumer, whenever he is buying in a supermarket, he looks at various label claims. Based on that, they try to buy the food. Okay? And apart from that, the changing climate and agricultural practices. And the substances which pose risk to the food safety. Basically, contaminants in the field like environmental contaminants, like dioxins, polychlorinated biphenyls, trace elements, metals, then the natural toxins like mycotoxins, plant toxins, etc. Then the residues like pesticide residues, wet drug residues, and contaminants while processing like processing contaminants, additives, illegal dyes like Sudan dyes, then packaging migration, etc., etc., etc. There is a whole big list. So when we talk of food safety testing, the food safety testing is predominantly, it is something we are used to make the analytical samples acceptable, homogeneous, and respect to analyte distribution prior to removal of any analytical portion. So we will, for the best gold standard guidance document, what is referred across the world is the SANTI document. The latest version is 11312. Okay, so it's basically updated. SANTI document is updated every 2 years. So this is the latest document which is being implemented from 1st January 2022. So the SANTI document addresses right from sample preparation, separation, identification, confirmation, quantification, data interpretation, and data verification part. So we will have a quick look at sample processing and extraction. So as on today, you might have learned basically to set up the experiment, what are the method parameters, okay, what is the desolvation temperature, how to tune the compounds, right? Okay, now we are going in a process of multi-residue analysis wherein we will be taking 2 representative commodities. Okay. So the sample processing and extraction, what did we get? Basically chopping, grinding, homogenizing, freezing, etc. And dilution, liquid-liquid extraction, protein precipitation, QueChERS, these are the ways, and ultimately getting through the analytes, and much more like fats, phospholipids, pigments, salts, sugars, etc. For a laboratory, the whole process is right from sample processing, analyte extraction, sample cleanup, separation, detection, and reporting. This is your whole circle, of which sample processing, analyte extraction, and sample cleanup, the 70% of your time you are spending over here. 70% of your time you are focusing on sample processing, analyte extraction, and sample preparation, and rest of the 30% in terms of the separation, detection, and reporting, which includes the data interpretation and data verification. Now, today morning, we had various discussion pertaining to the how much cleanup is actually needed, right? We had quite a lot of discussion. So, the limit of detection to ensure compliance with the legislative limits, either it can be MRLs, maximum residue limits, MRPLs, minimum required performance limits, reference point of action, RPAs, RCs, recommended concentration, etc., etc., etc. Okay? And the analytical technique used, basically selectivity detection, a high resolution mass spec, or a tandem cord MSMS. And simple cleanup of major interferences may be sufficient. So, as one of our colleagues sitting over here in the morning, they discussed, like, for the specific detectors, either it can be LC, UV, fluorescence, or GCFID. Here, the sample preparation requirement is much more as compared to the LCMS, GCMS, single cord, or the MSMS, or the high resolution mass spec, or the exact mass. Right? So, a tandem cord or a triple cord wherein it's a unit mass resolution, and when we talk of basically a high resolution mass spec, basically we have a strength that we get the exact mass, elemental composition, exact mass MSMS, wherein we can understand what are the functional groups which are breaking down, then the probable structure, and match up with the open domain library. Now, the challenge is creating a single extract method. Basically, first and foremost important is compound diversity. Large number of diverse groups and classes. Then different physical and chemical properties. And the most important, the matrix complexities, the matrix effects, protein, so it can address a wide variety of matrices, and right from the simple to the complex matrices. A dispersive SPE, okay? Just a quick overview to have a dispersive SPE, solvent and sample extracted, added to the centrifuge tube and shaken. Then sample is filtered or centrifuged. Then filtrate or supernatant is collected for the analysis, and matrix interferences are retained on the sorbent. So, here you can see sorbent matrix retention, analytes present in the extract, and sample is not concentrated. And cleanup options for dispersive SP. There are various solvent choices you get. It's a MgSO4 is standard which removes residual water, which is important for GC analysis. Okay. PSA, that is primary and secondary amine, removes acids, sugars. Graphitized carbon black removes the color interference, either from chlorophyll or the pigmented, some of the fruits and vegetables, like say for example okra, tomato, X, Y, Z. Okay? And C18 removes fats, oils and non-polar compounds. So typically when we summarize the QueChERS method, okay, with the dispersive cleaning options, if we have a combination of all these, this is ideal to remove fats and sugar. Okay? With the addition of graphitized carbon black, we are removing the chlorophyll and pigments. Sometimes there is a possibility that while using a graphitized carbon black, there is a possibility that adsorption of the planar pesticides may be on the graphitized carbon black. That need to be taken care of. This is an example of 212 pesticides in okra using a disc dispersive SP cleanup, this QueChERS, and at the level of 10 ppb level. So here you can see our target is in the range of 70 to 120. As today morning again we discussed, we should be as close to 100%. Okay. So here in majority of the cases you can see, except some of them, in majority of the cases the recovery is somewhere in the range of 90 to 100%. Some of them, in some of the cases, it is around 80%. Then this is a quick example of pass-through SP. So pass-through protocol, it's a pretty simple protocol. Load and collect, that is interferences are retained and analytes are passed through. Then rinse, collect and analytes are passed through. So these are the typical examples. This is one of the example pertaining to the cucumber extract. This is the waste and this is the collect one. And here there is a comparison of various pesticides, basically, which are wherein the recovery studies are done for pass-through SP, and typically 3 matrices were chosen, that is cucumber, grape, as well as rice. So basically, the solute interacts with the stationary phase and elutes after the void volume. Retention time is taken, is the time taken from solute to pass through the column, calculated from injection to detection. And why this slide is important is minimum, as per Santi 11813, the minimum acceptable retention time for the analyte should be minimum twice the retention time corresponding to the void volume of the column. Okay, it should be twice than the void volume of a column. So the void volume in the column which is not taken up by the stationary phase. In a column, in every column packing there is a void volume. So typically when you see over here, sorry, when you see over here, the minimum acceptable retention time for the analyte should be twice the retention time corresponding to the void volume. So if it is void volume is in this slide, it is shown 0.7, so it should be after 1.4, or the void volume is 1.774 ml. This is a typically which is calculated over here on a typical column chemistry, which should be, I think the column ID, it is 3 mm into 100 mm, which is taken into the calculation. Or nowadays most of the columns are 2.1 mm into 100 mm ID. That is the typical column for majority of the applications people are using. The 50 mm ID column also people use where they are looking for the single analyte method, especially for the bed drug residues like chloramphenicol or nitrochlorine metabolites. Okay. Then let us quickly look at the chemical factors that impact the selectivity. This is, as we have quickly seen, the stationary phase, the organic modifier, the mobile phase, and which is selectivity is very, very vital of that. So here is an example. So how stationary phase impacts on the selectivity of the pesticides. So all columns ran with 0.1% formic acid and methanol. So here you can see these are the 4 compounds. So whether it's clear or not, I don't know for you. Here couple of the peaks are coeluting. In this case also couple of the peaks are coeluting. Here also on a couple of the peaks are coeluting on this column, and here we have fairly CSSC18 fairly okay separation over here. When we see there is a separation basically with here a formic acid in acetonitrile, and here it is with methanol. When we see a comparison which is with a organic modifier on C18, here CSHC18, you can see all the 4 peaks are separated well. On QuEChERS, all the 4 peaks are separated well. On HSST3 column also, you can see all the 4 peaks which are separated well. And on VSC18 column also, you can see all the peaks which are very well separated. So basically the effect of mobile phase flow rate and resolution when using a gradient method, resolution can be estimated by calculating the peak capacity, and it is basically maximum number of peaks that can be. Then here you can see the ion ratio tolerance. Basically this is a resin matrix which is bit complex as compared to the apple, okay, but your tolerance either in resin matrix as well as in case of the apple matrix, the ion ratio from sample extracted should be in the range of 30% of average of calibration standards from the same sequence. This is one of the key requirement for the confirmation. And parameters and acceptance criteria for pesticide method validation, the linearity curve, residuals less than plus or minus 20%, matrix effect comparison to the response from the solvent standards and matrix mix standards addressed in the calibration if suppression is more than 20%. So you need to know what is the percent of matrix effect. Okay, the yellow Q should be lesser than the MRL, ideally, you should validate a method at half the MRL. Why half? Because in international trade, a 50% uncertainty criteria is applied to your analytical results. Okay? So, as we have discussed, trueness 70 to 120%, that is in terms of recovery. So, ideally, the range, typical range is 70 to 120%, but we should be able to adapt at, we should be able to achieve the range of 90 to 100%. And percent RST less than 20%. And robustness, it's basically average recovery and percent RST derived from the ongoing method validation and verification. So, conclusions. Multi-residue analysis allows for streamlined workflow, better asset utilization, sample preparation need for the generic method to cover multiple commodities and a wide range of pesticides varying from physico-chemical properties. More complex matrices like food oils may need a specific sample preparation and cleanup. As we have seen, we need a bit of modification and separation. Basically, mains C18 options, optimizing stationary phase, mobile phase, composition, and flow rate with a result in more robust methods and detection. Various ionization modes of the tandem cords are available. Then SANTI guideline provides a guidance on the validation and peak identification criteria amongst other key aspects regarding the analysis of the pesticide residues. So this was a quick. These are some of the quick details. Basically, before we start developing the method for the multi-residue pesticides, these are some of the practical consideration you need to focus on. Thank you.
Coming up next on GFoRSS TV.
We are delighted to welcome with us Mr. Jerry Chechet Kahu, Principal Regulatory Officer at the National Agency for Food and Drug Administration and Control in Nigeria, the NAFDAC. Hello, Mr. Jerry, and welcome with us.
Thank you very much.
So, we would like to share a few ideas and discuss with you mainly about the pesticide residue analysis, which is the main topic we are tackling today. So what are the main activities related to pesticide residue analysis in food and the main food matrices you are analyzing nowadays for that purpose?
Okay. As from the introduction, I work with the regulatory agency responsible for regulating and control the manufacture, importation and exportation of food. We are also the key drivers on food safety in Nigeria. We are actively involved in pesticide residue analysis. Recently, we've been having some rapid alerts on high levels of pesticide residues in our exported products. So the agency has really put forward a team to make sure that we try to find the problem and curb the resulting high levels of pesticide that have been experienced in most of our products that have been exported. So the agency is really putting more efforts in building standard laboratories and equipping those labs, and even training of analysts to ensure that these pesticide residues are competently analyzed within the laboratories.
who are your main stakeholders in this field?
Okay. We, as an agency, we collaborate with a lot of local and international stakeholders. Locally, we have collaborate with Standard Organization of Nigeria. They are responsible for setting standards within the country. We also collaborate with the Consumer Protection Council, who always fight for the rights of consumers in terms of food safety issues and other relative issues. And we also collaborate with the Ministry of Agriculture, specifically the National Agricultural Quarantine Services. They help in coordinating the activities of pesticide use in farming. So we have also international collaborators. We collaborate with the United States Department of Agriculture, the United States Food and Drug Administration, and we also collaborate with WHO. Recently, we achieved the global benchmarking tool of maturity level 3 under the WHO guidelines. So we have a lot of international collaborations now.
Okay, great. So you mentioned capacity enhancement, laboratory capacity enhancement. Can you share with us a few words about your perspectives in this field? What are the main perspectives you are aiming in the field of capacity enhancement?
Yeah, majorly is to build technical skills in multi-pesticide residue analysis, and in doing that, I think I am trying to guide my home laboratory to achieving the ISO 17025, and also, if in the future, make the laboratory to become a reference laboratory for food contaminant analysis within the country. So I think I'm going to work on that, and this training is really giving me an opportunity to build more capacity for pesticide residue analysis.
Thank you so much. We wish you all the luck in all your endeavors.
Thank you very
And we
much.
are delighted to have you among us during this training ongoing now at the Dubai Center Laboratories.
It's my
Thank you
pleasure.
so much, Mr. J.
And thank you very much.
Coming up next on GFoRSS TV.
Yes. So, hope everyone had a nice workshop. Then, now we are going into, after the method development, then we are going ahead with the different matrices. Okay. So, when we talk of matrices, the determination of the matrix effect is very vital. Okay, because this is one of the scientists' requirement also. Now, matrix effects in LC-MS. So, matrix effects can cause ion separation or enhancement, both. It's not always a separation, but it can cause enhancement also. So, this is, you can see the electrospray, what you yesterday learned. These are the LC elutant, and the matrix ions, these are in pink, are the matrix ions, and these are orange are the analyte ions. So, the larger droplets containing the multiple ions, then solvated ions formed as the larger droplets breaks apart with via various mechanisms. Okay. So, the ion separation of the matrix, induced ion separation, it is basically relative to the analyte acquired in the solvent. The same concentration yields a lower response when acquired in a more complex matrix. Example, the food matrix. So we are focusing here on the food matrix, wherein there is a possibility of ion separation, and now there is a possibility of enhancement of. Yeah, perfect. So ion enhancement or a matrix induced enhancement relative to the analyte acquired solvents, the same concentration yields a higher response when acquired in more complex matrix. So typically what we mean to say that matrix effects not only suppresses the ions, but at the same time it enhances. And matrix, all components in the sample that are not the analytes of the interest. So always in the residue analysis we say that what we are looking is the needle and a T stack. There is a huge amount of matrix. Huge amount of matrix, and basically matrix effects also, as per the SANTI guidelines, it should not be more than 20%. So effectively you need to have a process wherein you are going to measure the matrix effects. Right? So when calculating the matrix effects as a factor of a single concentration, matrix factor is P by A, which is basically a solvent standard, an analytical standard, spiked into solvent similar to the extraction solution to a known concentration. Then matrix matched extracted standards, matrix sample spiked post extraction to an equivalent concentration as a solvent, wherein you can see A is response achieved in the solvent standard and B is response achieved in the matrix standard. So when we talk of standard, always keep in mind it is a certified reference material. It's always a certified reference material. Okay? Because in any kind of residue analysis, you are supposed to use the certified reference material, which should have a complete traceability. This is as per the requirement of 17025/17. Okay? And C is response. C is response achieved in the matrix during the procedural standard. So what is a procedural standard? It's a matrix spike prior to the extraction, ensuring the final concentration of the extract similar to the standard. So this approach takes into account the analyte extraction and the matrix. So these are all the procedures we will see in the practical, taking into the tomato as a matrix today. Okay. So we will be focusing on first is a method development for 204 pesticides, and then in a matrix of tomato, basically the method development. So what are the things we have discussed today pertaining to the method development? That is a LC parameter. What is the cone voltage need to be applied to get the appropriate parent ion? What are the collision energy to get the two transitions, and also the RT. So RT, as we were been discussing since the morning, it is specific to the specific column chemistry. In case of change of or equivalence column is used, generally the RT shift can be expected. Now, when you are using on the instrument, that was more of a manual process, but when you are using on the instrument, here are the tools which you have in the target links. Target links is a patch in the mass links. So the mass link software, basically we call it as a quantification workflow software, wherein yesterday you have seen about the IntelliStart, then QC monitoring. Quanpedia is a database wherein you can extract all the methods, okay, pertaining to the compounds. which includes the LC as well as the MS parameter. And for processing, we are using the target links. So target links is a software basically which was developed you have a proper sample data. Yeah. So a red chili powder wherein there is a high amount of pigment, red pigment in that, and always it is difficult to estimate the target analytes unless and until you use a proper sample preparation. Probably we are using, apart from a QueChERS approach, we are using a bit of graphitized carbon black to get rid of the colors over there. And here it is one of the example, basically determining the matrix effects in a single concentration. This is an example of fipronil. Fipronil in egg. So fipronil in egg, you can see there is a huge amount of separation. I will not use something problem. I will use the slide. That is better. Okay. So here the other matrix what we are using is basically a soybean extract. In case of soybean extract, you can see the matrix enhancement over here is 40%. But at the same time, when you see for the suppression, there is a suppression of fipronil in egg, it is a minus 25%. So it is again, the equation is B by A, wherein B is 57,578 divided by 80,000, which is minus 28%. And here it's a 35,000 divided by 25,000, which is again a 40%. Yeah. One is color is a biggest problem. Another is some of the fats. Yeah, fats, sugars. So that's the reason we try to effectively use sample preparation, and in some cases we recommend to use an additional step of cleanup also. Most of the time, if it is like commodities like okra, commodities like chili, where the pigmentation or color is pretty high, there generally there is a ion separation problem. Most of the time it is ion separation problem. And in fact, there is a recommendation that depending on the sensitivity of your mass spec, you can use the thorough sample preparation if the sensitivity is low. Although your target concentration is 10 ppb, you can use thoroughly sample preparation when your mass spec sensitivity is low. If you have a moderate sensitivity mass spec, you can use a moderate cleanup, and a pretty high sensitive mass spec nowadays, new gen mass specs, which are pretty high sensitive. In some cases, you can use a dilute and shoot approach also. For all the three mass specs, we are using our target limit is 10 ppb. Ideally nowadays what we say that you should be able to validate a method at half the MRL. Because from the first day of the training, what we were focusing on is a measurement of uncertainty. A 50% uncertainty criteria is applied on your analytical results. So that's the reason in international trade. So ideally, you should validate the method at half the MRL.
I just tell some small explanatory things. See, when you think of matrix effect, basic problem came up that whenever any laboratory, they started working with pesticide residue analysis, they found that many times the residue level which they are supposed to get is below the accurate result or above the accurate result. Okay, so what happens that when your value is, for example, if the value is 0.05, maybe the instrument is measuring it as 0.02. Why? Because if 0.05 has a signal of this, after LCMS analysis, the signal is coming like this. This is for solvent standard, and this is the sample. Okay. Now, sample, normally you don't know what is the concentration, but suppose you take a blank and you add 0.05 quantity of pesticide, say carbendazim, then the instrument is measuring 0.02. So then it became a big question that why it came up. Then a simple answer was that when you inject it in solvent, peak is this much big, but when you inject it in sample matrix, peak has become small. Okay, or it's possible that the peak will become like this. So then it is say it becomes 0.08. So matrix effect basically is depicted in terms of signal enhancement or signal suppression. So question is that why it happens? Why Sante says that the recovery percentage should be between 70 to 120%. It could be less, it could be more. Actually, our expectation is 100%, is it not? Whatever value is that, we should estimate that value. You are spending such a huge amount of money to purchase CMS or GCMS. Despite that, if you are getting only 70% accuracy or 120% accuracy, then the question comes that how the technology is supportive to us. But there are certain realities. What happens?
That's what I was telling.
Yeah.
Practically, when you spike 10 ppb in a matrix, ideally you should get out 10 ppb.
10 ppb.
Most of the time you get 9 ppb, 8 ppb,
Huh.
sometimes 11 ppb.
Sometimes 11 ppb, 12 ppb.
12 ppb.
So one situation is that even if you prepare matrix match standard, you should remember, suppose if you purchase 12 mangoes, 1 dozen mango, you eat one mango, it's very sweet. You eat another mango, it's not that sweet. You take the third mango, it's also sweet, but not as sweet as the first one. You take the fourth mango, it's basically sour. So although all these are ripe mangoes, you understand that they have a biochemical compositional difference. So if you prepare matrix match standard or matrix match calibration using mango, you can't use a matrix match calibration for that particular sample. So naturally, your sample and your matrix, they may be different. So that's the reason, even if you prepare matrix match standard or matrix match standard calibration, it's possible that that is not going to correct your recovery.
Yeah.
It will not be 100%. It will be very close by. Many people in many training, they say that why? Then what does it mean by matrix matched? Matrix matched, can you really match?
No.
Every fruit, every vegetable, every berry. If we have 10 tomatoes, each tomato has different taste.
Yeah.
So these do not require any chemical analysis. We understand that. So if you understand the philosophy, then probably you will start like COVID-19. We have understood that we have to live with it. So every residue analysis expert or every residue analyst should take matrix effect as a part of his friend group.
Yeah.
And try to keep it in a minimized level. So here I have tried to give some depiction. Like we have two instruments. One is GCMSMS, another is LCMS. Normally in GCMSMS, we get signal enhancement. And in LCMSMS, we get signal suppression. Why it happens? Because mechanism is slightly different. In a GCMSMS, main culprit is liner. Have you seen liner in GCMSMS? We have injector port and there is a liner. Through that, Amin is a GC expert. So now this liner, they will have some active sites. Okay? So when you pass your solvent standard, pesticide goes and give a signal. And it's possible that in these active sites, some of the molecules will get absorbed. When you inject a solution in matrix, what happens? Matrix will have lots of biochemical compounds like polyphenols, etc. Now these polyphenols preferentially go here because they are plenty. Our pesticide is small concentration, but these biomolecules are quite large. So they will basically block these, and it's just like a VIP. A VIP enters, very important person enters, entire crowd gets separated and gives a channel. So Esther came out, and then she found that a proper channel has been prepared, and she just walks out as a very important person. So when you do your sample, what happens? This block goes, these blocks go. They are occupied by the biological molecules. If under this situation, when this was the thing, if 50 molecules have passed out and gave a peak like this, after these blocks are gone, peak may become like this. Signal enhancement. Because everything came out. But in solvent standard, nothing was there to block. Because in solvent standard, you had solvent and your pesticide. But in your matrix, you had solvent, your sugar, fatty acid, polyphenols, proteins, amino acids, whatnot. Everything is soluble in acetonitrate. Yes. Solvent. No, that is the problem. No? If you use a solvent standard, main problem is this. If you use that, if your original concentration is this may come like this. If you, for example, I think you had a calibration line here in earlier chromatogram. So you see, this is the problem. So, for example, if this is your standard calibration, आपने तो बैठी थोड़ा सा वो back block हो रहा है. If this is the standard calibration, you can see it here, no problem. If this is the solvent calibration, if your matrix match becomes like this, the actual concentration instead of here, it will come here. This is the difficulty. Matrix matched means what? We should want that these two should not have difference. That is the idea. Because this is the actual concentration. But because of something, your signal got suppressed like this. Instead of coming here, it has, why it has come here like this? Because peak has become shorter. Or it is possible that this is your solvent standard in case of GCMS. This can be your solvent standard calibration. This can be your matrix match standard. If you estimate in relation to solvent standard, there is an apprehension. Because in the first day when we delivered the first day of the course, it was mentioned that in a QueChERS extraction, when you just take some sample homogenate, you add some acetonitrile, you add magnesium sulfate, sodium chloride, shake it and take the thing out and do a nominal cleanup. Your extract is not very clean. Your extract is quite dirty. You are heavily dependent on the selectivity of a mass spectrometric instrument, that too which works under tandem mode, MSMS. So this is the unique combination which is the success story of QueChERS method. QueChERS method and a single quad will be extremely difficult. It's a very, very difficult. So because there will be too many peaks because of full scan. We have plenty of, are you doing analysis in the lab? So you will find a lot of experience like this. In LCMS what happens, main culprit is ion source. Here what happens through the HPLC column when it comes out, your pesticide plus water plus methanol plus some buffer, everything comes together. So there is a competition, because in ion source electrospray ionization you are putting a high voltage. One high temperature is applied so that all solvents get evaporated and high voltage is applied. So because of that, so this you see that from LC column it comes out. And I was telling that this is never like this. This is never like this. This is not never aligned like this, because we want some selectivity here. We don't want everything go through this hole, small hole, because once it enters the hole, then it's entirely vacuum. This part is under atmospheric pressure. After this, everything is in vacuum. So some sort of selectivity is required. So here basically solvent gets evaporated and your compound gets ionized. Now during ionization, if the molecule has so many things in association, like it has sugar, it has fatty acids, it has many other things, they will also ionize. So it's a competitive ionization. If all of us want to go out of this, there will be huge competition. So the person will always find lot of difficulty. So in this case, but for example, if for him it's straight, he goes out. But for person like Abdul Kabir, if he wants to go out, it's not easy. So then if it is a single molecule, it's very proper, very nice analysis. But if it is in a complex atmosphere, like the way Abdul Kabir is sitting in a matrix, lot of people around, it's not easy for him to go out. So in that case, his signal will be suppressed. You understand? So this is the difficulty. So if you think of matrix effect in a physical mode, in a real life situation, probably it's very easy to understand. Nothing physical chemistry, no physics, nothing. Just think of a real life scenario. Then you will understand what is matrix effect. Matrix matched standard is the only solution. If the laboratory has good amount of money, they can also purchase the internal standard. Every molecule these days may have some or other internal standard. But fortunately, most of the pesticides, we solve the matrix effect by applying matrix match standard. For few compounds, you may require some internal standard.
In some cases, that is also done through the standard addition process. So, in general, when we look, suppose you have a, I'm just taking a sensitivity for the solvent standards is 0.1 ppb. Generally, as a rule of thumb, you will get 10 folds higher in when you are doing through the matrix. Generally, okay. And the second thing is whenever you are using a during the sample preparation process, whenever you are using a graphitized carbon black, ideally it's an ideal tool to get rid of colors. But at the same time, some of the planar pesticides can absorb on the graphitized carbon black. So that also the care need to be taken. And here, how Dr. QuEChERS sir explained that here the whole purpose is in a mass spec, you need to have more and more resonant ions entering the mass analyzer. What are the resonant ions? Resonant ions are the ions which travel through the various quadrupoles Q1, Q3 and go to the detector. Non-resonant ions are the ions which decay during their travel process. So we need to have more and more resonant ions. So nowadays the new generation mass specs are designed in such a way that effectively they eliminate the neutrals and the charge ions are moved into the mass analyzer. So most of the mass specs, they claim that the transmission efficiency is 100%. So we were so in some of the mass specs there are features like I don't know what happened to them. Something in the slides. Okay. Oh, I have to add some time. Oh, sorry. To keep up with the time, I have put every slide with a certain time. Okay. Okay. So in nowadays there are various mass specs wherein you can do a screening, quantification along with the matrix background monitoring, everything in a single run. And some of the mass specs are with a combined source, that is ESI and APCI, which is ideal for the method development. That means in a effective, ideally what I can say that in a single run, you can have ESI positive, ESI negative, APCI positive, APCI negative, MS and MSMS along with the matrix background monitoring, everything in a single run. That kind of experimental choices are also nowadays available. Okay. The advantage is here with these kind of approaches, you can really monitor what is the matrix background. So if the matrix background is high, you can again rework on your sample preparation. So you can rework on your sample preparation. That will be very, very helpful for you. So these are the kind of matrix diversities. You can see the matrix background at the same time your target analyte. So this is a pretty helpful process. I don't say that this will remove the matrix, but you can rework on your matrix. So in summary, chemical structure of the analyte and matrix may result in components competing for the charges at the ionization. Matrix effect should be determined using the matrix match standard. Okay, that is vital to account for inefficient extraction or the recovery. And comparison of the solvent and matrix standard should be made under the same condition. Under the same condition, comparison of solvent and matrix standard should be made under the same condition, including the solvent diluent, MS parameters, concentration, as well as the injection volume. So The extent of matrix effects can vary from analyte concentration, commodity type, and the base from which we get the sample. Typically, a good rule of thumb, effects should be less than 20%. And less than 20% should be, if it is more than 20%, it should be corrected. And it's typically nowadays, it's a scientist requirement. Nowadays, the new regulation of 2021-808 for wet drug residues, EU wet drug residues, they also say the same thing. So, less than 20% has become a benchmark. So, better all of us follow the same.
Coming up next on GFoRSS TV.
I would like to welcome for this section Dr. Paul Osei Fusu, Head of Food and Agriculture Department, Chief Scientific Officer at the Ghana Standards Authority. Welcome, Dr. Paul, with us.
Thank you very much.
We would like also to share some insight with you, particularly related to the training you are actually participating to at the DCL. So in terms of laboratory capacity in African countries, can you give us some insight about the current situation related to pesticide residue analysis?
All right, thank you. I'm coming from a standard organization, and our core work is to develop standards, also to have conformity assessment and metrology. But under the conformity assessment, there's a need for testing. So our lab at the moment have some labs that are accredited in this area, in which we have the pesticide residue laboratory accredited, we have the metallic contaminant lab accredited, we have the mycotoxin and histamine lab also accredited, the microbiology also accredited. In this area, to me, yes, there is some form of capacity building that is going on in Africa, but there's a need for us to improve upon it, because looking at where I'm coming from, Ghana, yes, we're doing a lot in this area, but looking at the situation globally, there is a need for us to increase the capacity of the lab so that we can really do a lot for the continent. Especially, most of our products are exported, and there's a need for us to do testing in this particular area. So there's some work have to be done in this area.
Okay, thank you. So in this context, based on your knowledge of this field, as you were just sharing with us, what might be done in this regard, and what are the potential solutions for these challenges?
What we can do, yes, is to build capacity, in which, luckily for us, some of us have the opportunity to be here to learn. So there's a need for serious capacity building in this area in Africa. Apart from building the capacity, I think the area of lab building, yes, infrastructure in that area is key. We need to equip the labs with the requisite equipment, because looking at the trend that we have in, especially pesticide residue and aflatoxin, where you need an LC-MS to do your work, there's a need for some form of work in this area, especially if government can, yes, allocate some money so that each country can have a lab dedicated for such work. It will be very, very good, and it will help the continent.
So during this training you are participating to, what are the key messages you can share with us, and what do you think is their most efficient implementation strategy?
All right, thank you. At least per the training, we had a lot of insights in method development, how to quantify your work compounds, how to do your analysis, and what we went through is to help us to look at the modern trends. We the work that we did, we were using the QueChERS method, which is one of the methods that is being implemented now. So it has really helped us to know that this is the trend that is going, and we need to move along that line. Per what we've studied, I think as participants, we have to go out and also train our people in country and build a capacity along that line so that the knowledge sharing can go on. Capacity is key. So that is one thing that I think we have to do. Secondly, as a participant, yes, we have to ensure that we have links among ourselves so that we can coordinate in one way or the other. So this will help us. But I also think that each participant should come out with a roadmap on how he or she is going to implement this in his country, so that it will help us in evaluating the training that we've all received. And I think as part of the training, I'm going to probably convince my colleagues for us to do that, so that it will help in moving out this particular training ideas.
Thank you so much, Dr. Paul. Thank you for your presence with us today.
Thank you very much. You're welcome.
Welcome to the African Food Safety Laboratory Capacity Enhancement. Announcing Phase 2 of the Africa Food Safety Laboratory Training Initiative. From 24th of July to August 3rd, 2022. Hands-on training for 10 African scientists on analytical applications for pesticide residue and mycotoxin determination in food, used for regulatory purposes. The training is held at the Dubai Central Laboratory, Dubai Municipality, UAE, towards the setup of the Dubai Center of Excellence in Food Regulatory Science. This training is funded by the USDA and the USAID, implementation by NEF, Université Laval, in partnership with the Global Food Regulatory Science Society, GFoRSS.
Thank you all for joining us during today's session, dedicated and devoted to pesticide residue analysis. I hope you enjoyed the various sessions presented by our speakers, dealing and tackling sample preparation techniques linked to multi-residue pesticide analysis, other technical considerations, particularly matrix effect and its management approaches. I would like to convey my thanks again to the Dubai Municipality, particularly the Dubai Central Lab, for their continuous and unwavering support during all our activities. I would like also to thank Dr. Eli Bouyazbek for all his efforts deployed during the past weeks and today to make this idea of a TV dedicated to food regulatory sciences a reality. For the upcoming period, our TV will have continuous broadcast on as announced basis, so please stay tuned by connecting, following, and subscribing to our social media platforms, and by providing us with your suggestions. Thank you so much.
You are watching GFoRSS TV. Today, on GFoRSS TV.
the Global Food Regulatory Science Society. GFoRSS mission includes knowledge generation and dissemination, underpinning food regulatory decisions, in support of food control systems, Our interventions focus on promoting food regulatory scientific disciplines. Consistent reliance on food regulatory sciences enables robust food control programs. Contributing to more resilient food systems and a safe, accessible, abundant and nutritious food supply.
Thank you for watching GFoRSS TV.